Hello everyone, this is Dr. Lashik, and this lecture covers the second part of Chapter 7, so interrogating external validity. When assessing frequency claims, considering our external validity is probably the most important out of all of the validities. For example, if we're considering the frequency claim that 50% of United States teenagers would like to have children when they grow up, who they sampled, so who they selected to participate in their research, and who they've decided represents all American teenagers is very important when interpreting whether or not we can trust this statistic. Sometimes, though very rarely, we can actually confirm whether or not our external validity was really great or poor. For example, with polling estimates, which it means polling estimates are predictions about who will be elected, we can actually confirm our external validity because when the results of the election come forward, we can see if our sample actually did represent the population by the accuracy of our polling estimate. Most of the time, however, we cannot check for our accuracy, our external validity accuracy. There is no proof after the fact. So why is this important for us? Well, as consumers of information, we have to interrogate what we read and decide for ourselves whether or not the researchers' external validity and sampling techniques were good or poor. So the general rule of thumb is if a researcher uses random sampling techniques, we should feel confident that the external validity is just fine. So that's the general rule of thumb when interpreting research, because there is really very few ways to confirm, especially in psychology research, whether or not our external validity was great or poor. Sometimes the things that make the sample biased have absolutely nothing to do with the results, and therefore, in those rare cases, external validity doesn't really matter. There's very few situations where this is true. There's very few situations where external validity is irrelevant. One good example of such a situation is a radio station who acts as researchers for a moment when they are taking callers from listeners who are reporting on whether or not the highways they happen to be driving on are roadblocked, or there's been an accident, or there's high traffic that day. So what they're doing as the radio station, they're relying on a biased sample. The people who choose to call into the radio station to report such information are considered a self-selected sample who are probably very different than other people. They're probably more conscientious in that they have decided to take it upon themselves to make that call when they didn't have to. They are probably very different for a lot of reasons. They probably drive every day, which makes them different. They probably decide that this traffic is worse than the traffic on the other road that they were just driving on. And so it's a biased sample. But as a radio station worker, do you have any reason to believe that trusting that biased sample's information is a problem? Probably not. Not with the information. As a radio station in this example, we are just there to convey what roads have poor driving conditions. And in that case, it doesn't really matter who gave us this information. But there's very few situations where it doesn't matter, like our radio station example. Most of the time it really does matter, and most of the time it's hard to check. But we can use that same reasoning when considering the external validity of research studies. If we decide, when using our best judgment, that the biased sampling techniques that the researcher used doesn't matter for the results, then I guess it's up to us whether or not we interpret that research as though it's very valid or not. It is always, though, there's a lot of danger in coming to the conclusion that a biased sample does not matter, because there's always a slight possibility that the bias may actually have caused a difference in the results, whether or not we've decided that it didn't, right? So we have to judge whether or not that possibility is remote or very likely. So does the bias affect the results? If you think that it is very remote that the bias affects the results, then go ahead and feel free to trust the results. However, if you think it's a high possibility that the bias in the sampling does affect the results, then my best recommendation would be not to trust the results you are reading. We have to remember when thinking about sampling that larger samples does not necessarily mean quality samples. Larger samples do not necessarily mean more representative samples. Great example of this is you could ask the question, are there more liberals or Republicans in the United States? If you asked only one person, they'd probably give you a biased answer. Or if you ask only one person that you come across and whether or not they are Democrat or Republican, their answer does not represent everyone in the United States. You'd have to ask more people. But it doesn't necessarily, just adding a higher number to that doesn't necessarily mean you're going to get more representative. For example, you need more than one, of course, but if you go to a Republican National Convention to get your more people, it doesn't matter if you sample 100,000 more people, you're going to get biased information. All of those people are there for a reason, probably because they're Republican. And so you might come to the conclusion that everyone in the United States is Republican, whether or not that's true. So it's not necessarily the number of people, it's how you have selected your sample that's important. The number needs to be more than one. There's a minimum requirement, but it doesn't necessarily mean that you will have better results because you have sampled more people. Researchers have found that most polls only require at max 1,000 people, and that a sample size of 1,000 is enough people to represent even the entirety of the United States. Instead, researchers don't even need to go that high. What they need to do is find a sample size that makes their margin of error as small as possible. For example, let's say we have the frequency claim 53% of Americans are Republican, plus or minus 10%. What that means is that 53% is the value that they found when doing their research with their sample. The plus or minus 10% is their margin of error, and that what that is saying is that while we found 53% with our sample, because our sample may not represent the population perfectly, there's a good chance that the real value, if we were to study everybody in the entire population, would lie somewhere between 43% and 63%, so plus or minus 10% of that 53%. So that information is not very trustworthy. The margin of error is so very high that there's so much wiggle room. So if we heard that 53% of Americans are Republican, plus or minus 10%, that's not very trustworthy. There's too much chance for error. There's too much wiggle room happening. However, if we heard that same statistic, 53% of Americans are Republican, plus or minus 3%, it would be much more trustworthy. That means that while they found that 53% of their sample were considered Republican, that their sample does not represent the population perfectly, but it did so much more than the other sample, meaning that they only have a margin of error of 3%, which means that the population's likely real value of republicanism in the United States is probably somewhere between 50% and 56%. So that's a much smaller area that the real value could wiggle between, and we would be much more trustworthy. So as you can tell, randomness, or the technique, is much more important than the number, but the number still has its benefits. The number is primarily most important for decreasing your margin of error. And if you notice on the slide here, you can see how the margin of error is reduced by adding more people. So with 50 people, assuming that these people are all randomly selected, so assuming that the technique was upheld, you can dramatically decrease your margin of error. Going from 50 people to 100 people decreases your margin of error by 4 percentage points. But as you can see, there's a law of diminishing returns here, which is why researchers only say that you need only about 1,000 people to represent everybody in the United States. Because if you'll notice, going from 500 to 1,000 participants only decreases your margin of error by 1 percentage point. And so that is usually considered the max necessary amount, is 1,000. But researchers can toggle around between the different options of sample sizes to decide how that's going to directly affect their margin of error, and then make a good decision about how many participants to include based off of that information. All right, if you have any questions about this chapter's information, please don't hesitate to email me.